to Forrest and Eric. See where are they at here.
Yeah, we're ready to go.
Okay.
Eric, are you good to go?
Yep, that works for me.
How are you guys doing this tag team Zoom?
How are we doing it?
Yeah.
Forrest,
I'm gonna run. I'll run the slides, and then Eric will just tell me when to move on.
Oh, okay, that's great.
All right.
So,
just let me know when everybody sees my slides.
Yep.
All right. So we're going to talk about plugging and reclamation of orphaned wells. Eric and I are both representing the Orphaned Well Project, which is a nonprofit organization that we started last summer. Eric, if you'd like to introduce yourself.
Yeah, Eric Bruseth, graduated in 2019 with Forrest, along with DJ, who presented earlier. Spent most of my career with Packers Plus, lived in Canada, US, and Middle East, and put tools in the ground pretty much on just about every continent there is. So had some fun over there, and now I'm working with Forrest on the Orphaned Well project as the operations manager.
Yeah, and I'm Forrest Smith. I graduated in 2009, petroleum engineer. Just recently got my MBA from Oklahoma State University. My current role, I am the Chief Petroleum and Environmental Engineer for the U.S. National Park Service, but I'm also a co-founder and work with the Orphaned Well Project.
So a little background on what we're trying to do with the Orphaned Well Project. We're a nonprofit organization. We're getting together last year and just kind of kicking around some ideas, and thought plugging and banding wells would be a fun one, kind of suited all of our backgrounds and give us something to do. And what we're looking to accomplish with it is to educate and promote the awareness of what orphan wells are, what the reclamation process is, and besides the fact of actually plugging and banding wells. And the other big one we want to do is to give back to the community a little bit and create some jobs and get some positive publicity with the oil field.
Yep.
So kind of going through what an orphan well is. The orphan well is typically from a operator who's gone bankrupt. They do not own the well anymore. The well is typically unplugged and abandoned. No one owns it. The Interstate Oil and Gas Commission, Compact Commission, is saying there's 56,000 unplugged orphan wells in the U.S. And of course, since they're undocumented, the numbers change pretty drastically for the undocumented wells. There's numbers saying 200,000 to over 750,000 wells out there that still need to be plugged.
Yeah, and I think to add to that, Eric, there just isn't a lot of research, and there hasn't been a lot of time put into the actual study of just how big this orphaned well problem really is in the United States and in Canada. The numbers vary so widely that we don't really have a great grasp on just how big the issue is at the moment. So we'd also like to push for further research into this area with our nonprofit.
So looking at the with the bankruptcy of oil companies on the rise with our downward trend recently, it's sorry there.
So since the crash in 2008, we've seen a documented increase of about 12% of these abandonments happening, where companies basically just completely dissolve, and these wells just end up as wards of the state, either the state or the federal government. And typically they don't get addressed as fast as they could, just due to time by the state and federal governments and money in general.
Correct.
Yep.
And kind of one of the extreme examples found while doing some research, a school in Beverly Hills was stuck with 19 wells they had to abandon when a oil company that they were working with declared bankruptcy. The bill is pretty staggering at about a little over $500,000 a well, which is considerably more than the U.S. Government Accountability Office estimates of about $20,000 to $145,000 a well, which is typically what we've generally seen around the U.S., just kind of depending on the severity of the well and its conditions and things like that.
Yeah, the old petroleum engineering saying is, it depends. You know, it really, there are a lot of variables in how much it costs to plug and abandon these wells. Some of these older wells out in, you know, Pennsylvania that are 150 years old, they're basically a couple 100 feet hole in the ground with no casing. And they're relatively easy to plug. You just basically back a truck up and fill them full of cement. But there are some larger abandoned wells in, say, Western Montana, North Dakota, Wyoming, that are these super huge, very long lateral horizontal wells that have been abandoned. And, you know, these wells could cost $500,000 to $750,000 to abandon. So the numbers vary widely. It just depends on the age of the wells and how deep they are and a number of different variables.
And some of the impacts we're looking at, you're going to be concerned about the groundwater contamination through the wells, it leaking through the casing, through the cement. You're going to be looking for gas leaks, typically methane, and surface contamination, leaks, spills, things like that around the area.
Yeah, and you know, quite a few of these wells are leaking methane, which is a very potent greenhouse gas compared to CO2, almost 34 times the amount of greenhouse effect. You know, the U.S., you know, not enough research has gone into this, but we do estimate that you know, these wells are emitting about the same amount as about 2 million cars of greenhouse gas. So it is a very large impact to the environment. Just having these wells sitting unplugged and just abandoned. And you know, also to add to that, you know, surface locations can get pretty contaminated and littered. They're just generally out in the middle of nowhere, and they're open spots, so people will dump their garbage or what have you out there. So there's multiple fronts into why these you know, the impact to the environment and the local communities from just having these wells sitting abandoned.
Kind of what's being done to tackle this problem. There's multiple facets actively working on this problem. You have the Texas Railroad Commission, you know, a regulatory body working on unplugging wells. You have a fund in Oklahoma that's almost entirely made of private contributions from the industry. That's plugged an impressive 15,000 orphaned and abandoned wells. And you also have the federal government working through the BLM that's got about 295 wells. So they're trying.
They are trying, but you know, there is an enormous backlog of orphaned wells that remain to be addressed. And, you know, they lead to these impacts that we'd previously talked about. One of the issues is that, you know, the federal or state governments don't work fast enough to address these issues, mostly through either red tape or funding that comes from the government. And private businesses generally, they just don't have the time or the resources themselves to clean these up. You know, they may think that this is somebody else's problem, when in fact it's kind of an industry's problem that we need to take ownership of as an industry and start to clean up this mess. So that's where the Orphaned Well project that we founded comes in. We're using our team's decades of experience to address these orphaned wells within the United States. We want to direct and assist in any way we possibly can to help reclaim these wells, not just for the environment, but also for the local communities. We want to hire local workover crews that have possibly lost their jobs during the last couple of downturns and get some money back into these communities that have actually been severely impacted by the downturns. It's estimated that, by plugging even just 500,000 of these orphaned wells, we could create about 120,000 jobs over a few years to get these wells cleaned up. So that's a good amount of jobs, especially for the industry that's lost so many over the last couple of years.
And it's good publicity for us as an industry too. If you've watched a Marvel movie or something, at the ending credits, they like to say they've created 10 or 20,000 jobs through the creation of that movie. We could do something similar.
Yep. So how do we evaluate these wells? There are several software databases that we can use to research wells and well sites. Kind of look them up by age, whether they've been orphaned or abandoned by the various states that they are located in. We can also look into their environmental and community impacts, be it through methane leaks, oil leaks, groundwater disturbances, anything like that. The more the environmental impact, the higher on the list they would become to be addressed. We're also working in collaboration with a drone company that has various tools such as magnetometers or spectrometers. The magnetometers actually are very impressive because they allow us to see wellbores that have been buried over the top of and forgotten, and you really can't find them. You don't have good enough GPS locations, but they pull these magnetometers over the top of a field, and you can pinpoint the top of the wellhead within centimeters. It's very impressive of technology. And then they also have spectrometers that we can fly over a field and detect the presence of noxious gases coming from these wells. They also have imaging software, so we can see oil impacts, leaks from the ground that may not be visible just from the naked eye, but you can see the remnants from it just from the spectral images. So there's quite a bit of ways to evaluate these wells, and we would really want to address the ones that are posing an immediate hazard, but we do want to address all of them at some point. A little bit about the plugging and reclamation process. The objectives of P&Aing an operation, you want to isolate all of your fresh water zones. You want to isolate and protect any kind of future commercial zones, be that oil and gas, be that geothermal, or some sort of water zone. We want to protect leaks, so we want to make sure that we're not leaking up either through the casing or the annulus around it. And we want to remove all of the surface equipment and flow lines and everything at surface and bring that back to its pre-operation status. So just a little bit, we don't want to go too in depth on the actual plugging process. Eric and I could probably go on for hours on the actual intricacies of plugging a well. And maybe we'll do a tech talk at Tech sometime about that. But so you basically you're setting a series of cement plugs and cast iron bridge plugs up the well bores. You want to protect, first you want to block off your perforations, and this depends on state and federal regulations. Some states want you to squeeze the perforations completely, while some don't mind if you set a cast iron bridge plug and then a couple hundred foot of cement above the top of that bridge plug. You also want to protect any kind of water bearing zones, even if they are brinish or brackish. So you'll find those in your logs and set plugs above and below those to protect them. You also want to make sure that where your top of cement is on these wells, if it's too low, we want to go in there and shoot holes in the casing and plug the backsides with a squeeze. You also want to cement around your surface casing. Typically, surface casing, as we know, is set below freshwater aquifers. So you want to make sure that there's not going to be any mitigation from lower formations up into your actual potable water. And then you plug the top of your casing. Usually you'll weld a plate in place that has the well's information, And then typically these wells are buried below grade. Sometimes you may have a marker. It depends on where it is. If it's in a farmer's field, you don't want the marker because they'll run it over anyway. But there's a lot that goes into it, a lot of planning. You want to make sure you know where all of your zones are, how deep your well is, temperatures, pressures, all of that. There's a lot of engineering that goes into plugging a well. To the right, there's a little kind of graph there that shows you some of the ways that oil and other contaminations can enter these abandoned wells and then end up in either water wells or in residences or on the surface itself. It's an interesting little graph. And then the final step would be your plugging reclamation. So you want to make sure that once the well is plugged, the wellhead's removed, surface is graded, you're going to remove all of your well pad material from the site and take that to a proper disposal area. Usually those well pads will have some sort of oil or condensate contaminations. So you want to make sure that that's properly donated. You just don't want to move the pollution from one spot to another without it properly being addressed. Then the site is graded and it's seeded with natural flora, and then periodically monitored for vegetation growth and also for signs of leaks of methane and oil at the surface. Those can be signs of dead vegetation or grass just not taking fold. So that kind of concludes our talk with the Orphaned Well project. There's our website's our organization's website. So questions?
Any questions for Forrest and Eric? Not. I've got a few questions for you. So
Yeah. Oh,
go ahead,
sorry.
Sasha.
Okay. Hey guys, I don't know if you may have, heard me introduce myself earlier or whatever, Sasha linked, like I said. But I find this super interesting, actually. This is exactly in my wheelhouse right now. And now I'm not really so sure I can do this project because it seems like the proof of concept is proved. But, what I'm looking to do right now at Tech is getting involved a little bit with the professors who have access to the UAVs here at Tech, their equipment. And maybe trying to do a little bit of a collaboration with a nonprofit called the Well Done Foundation, based out of Shelby in Montana.
Yep.
And okay, yeah. So the premise of my project was using a UAV mounted methane sensor, to be able to go around and locate these, methane emission hotspots and be able to kind of map it out. And especially for him, he has a burgeoning nonprofit. So I think for him to get the most value for his money right now, he kind of has to triage, which wells are emitting the most. But sorry, my question is just wondering your experience with using these UAVs, to do this sort of thing, and have you run into any main problems like wind or anything like that, or too high costs, or?
Yeah. So with my my current position at the national parks, we've used these drones extensively to look for wells that have been abandoned within the National Park Service. Some of the biggest issues we've run into is wind. It's usually weather related. Also, some of these magnetometers need to be fairly close to the ground, within maybe 10 to 15 yards. And with certain areas, the tree line may be much higher than that. So you need to figure out a way around that. You can also, we've had to drag those magnetometers through the dirt. So we didn't have to use the drones in those areas, but we've only run into that in one park area. So tree line, height of where you're actually flying those drones was an issue, and then weather. But other than that, it's a really great technology because you can access areas where it's really hard to hike into, or some of these areas have become overgrown, or it's wonderful. I really like it. I think it's great. It's a good use of technology. Awesome. For sure.
That's really great. Well, I'm glad to hear that for sure. Well, no risk of too much of a tree line in northeastern Montana.
Yeah, not in the high line,
Montana. Right? Yeah. Thanks.
Yeah.
Did you have a comment?
I have a question.
Yep.
Go ahead, Lee.
So yeah, Forrest, I might have kind of missed it, but I mean, do you see how are you getting your funding, and what do you see as the future for funding of this? I'm involved with the Well Done Foundation. We're working with their, working on some novel cement there with them too. So I'm very interested in all of this as well. So,
Sure. Yeah. So we're fairly,
so
we're fairly young. We're still, kind of trying to figure out ways to actually fund this. We're thinking of going through private donations, or either soliciting companies that could help us with this, give them some kind of good publicity. They could put our seal of approval on their website and say, hey, we're helping out. Another option we've been looking into is once we've properly documented the methane and CO2 that are leaking from these wells, we could come up with some sort of a carbon credit unit system to where companies could purchase, say, X amount of carbon credits from us, and they would be good for the rest of the year. So that would give us some kind of funding that direction. Eric, what other options are we pursuing? I know there's a few more.
I think those are the big ones that we're looking at. Like you said, trying to come up with some sort of a branding.
Yeah, it's really about marketing ourselves, and we're all still kind of learning how to do that, marketing and branding and getting our name out. And all we need is that one viral video to go out and get everybody's attention.
So Forrest, there's a couple questions on chat about casing cutting and dressing, and they're wondering if the EPA plays a role in special in terms of funding.
Okay, yeah, let me see. Okay, so Calvin, I do remember Baby Jessica. I do remember that.
There's your marketing right there, Forrest. I mean,
right?
So I was going to ask you about your funding on the EPA. So I'm actually working for, my side gig is to help the DOT and the DOE and the EPA commercialize research that they fund.
Yeah.
Are you familiar with the SBIR program?
I am not. That's actually something I've not heard of. We
Small
were working a little bit.
Small Business Innovation Research. Check it out.
Okay.
You guys could get a grant. The minimum grant's like 100 to 150,000. Now you need to have some secret sauce, and maybe with Lee's comment, maybe there's some chemical, cheap slurry, cheap abandonment technology, some way that will interest them. But this would be a hot topic with the Biden administration and the the $2 trillion infrastructure spend. So your timing's right for this. So you might want to, if you want to bounce off some ideas, I'm happy to help.
Yeah, absolutely. I'll have to get your contact information. EPA plays a role. We haven't worked much with the EPA, but possible funding through the government, like Calvin was saying, the Biden administration's working very aggressively to address these orphaned wells. I know just from my position at the national parks, the Biden administration has pinged us many times about, hey, do you guys have projects that concern these orphaned wells? We've got the funding, just send us your proposals, and we can see what kind of money we can send your way. So it is there. It's just finding a way for a nonprofit to access it. Let's see, casing cutters. I don't know about that one. Eric, do you want to give that one a shot?
I don't see that question there. I see the EPA and the Baby
Oh,
Jessica.
it's to me privately. Sorry. What do they use for casing cutters dressing if there is a need for that on surface before welding the flat plate? I am not sure usually they just use a diamond chain saw from what I've seen. I don't think there's anything really too fancy for it. It's pretty simple,
That's what I'm familiar with as well.
Yeah, I've never seen anything more than that.
That would just really elevate the cost if you're just having to run casing cutters and cut below surface.
Yep. So yeah, anytime you're working with a nonprofit, it's about pinching pennies. So nothing too fancy.
Another comment I've got in the geophysics department, Xiaobing, Dr. Xiaobing, he's doing a lot of stuff with drones and hyperspectral imaging here, and he has funding through NASA and stuff, but he's always looking for interesting projects, and that might be
Okay.
a contact.
Yeah, I remember Zhao. He was my physics professor.
Yeah.
Yeah.
So,
Yeah, we'll have to reach out to him, Eric.
yeah, he's got a pretty cool drone.
Yeah, nice. Okay, wonderful. Well, is there any other questions?
No, and so let's see. If not,
Sorry, I got one more.
oh, go ahead, Calvin.
Have you thought about the geothermal angle?
You mean converting these wells over into some kind of a geothermal?
Yeah. I mean, if you did think about it this way, if you could high grade and offer geothermal companies, candidates for consideration, you might, and you could charge for that. That might be a revenue stream.
But no, that's actually a really good idea. I like that.
Yep.
Yeah, no, that's actually, I'm gonna write that down because that's something I'll definitely pursue. Yeah, I like that. Thanks, Calvin. All right. Thanks, guys.
Thank you.